All right, today we are starting Chapter 3. Chapter 3 is all about equations with two variables, so we're going to dive right into those today. Like I said, we'll have time to go over your tests and stuff too. You should have some time at the end for homework, so nice start to your Monday. Here we go. Part A. State whether each ordered pair is a solution to the given equation. So our equation is 7x minus 2y equals 0. So when you have an equation like this, there are multiple combinations that are going to work. Okay? And we list those combinations in ordered pair format. So the first number goes in for the x, the second number goes in for the y. If they work, it's a solution. If they don't work, it's not a solution. So basically, we're going to start by plugging these in and seeing if they work. Okay? Then we're going to practice how to find and how to graph all the other solutions as well. So, first numbers are x, second numbers are y. I am going to put the 2 in for the x and the 7 in for the y. Just like when we substituted previously, I'm going to leave them in parentheses until I know if the parentheses are needed. Parentheses show us multiplication. They also help us keep our signs straight. So 7 times 2 is 14 minus 2 times 7 is 14. And what's 14 minus 14? 0. So 0 equals 0. Is that true?
Yes.
Yes. So this is a solution. So your answer is yes.
This is fun.
It is fun. All right, here is the second one. So we are also going to test this ordered pair. So this is still example A. We're testing two ordered pairs. Do you remember I said there are multiple combinations that work?
Yeah.
So we're going to see if this is another combination that works.
You never know.
So when I plug 3 in for the x and 4 in for the y, I get 21 minus 8.
No.
Does 21 minus 8 equal 0? No. It does not. This is false, so this is not a solution. So in part B, we have a new equation. So 2a minus 3b equals 16. Typically, we call these x and y, but if there's more than... Not if there's more than one variable. There will always be more than one variable. If the variables aren't x and y, assume whichever one's first alphabetically is the first one in the ordered pair. So in this situation, the negative 1/2 will go in for A, the negative 5 will go in for B. So I'm going to do 2 times negative 1/2 minus 3 times negative 5. And if that equals 16, then this is an example of a solution. If it does not, then it is not. So what is 2 times negative 1/2? Negative 1. And then minus 3 times negative 5, what happens back here? It becomes a plus 15. Good. So negative 1 plus 15 equals 16. Is that true or false? No. That is not true. It actually equals 14. So that is not a solution. Your answer would be no. Here's another one we can test. Again, still part of example B. So I'm going to plug negative 5/2 in for the A and negative 7 in for the B. So that's going to be, the 2's are going to become 1's, right? So it's like 1 times negative 5, which is negative 5. Minus 3 times negative 7, so plus 21?
Yeah.
So negative 5 plus 21 is 16. Is that true?
Yes.
That is true. So this is a solution. All right, so now we're going to talk about graphing these. So when an equation has two variables, we can graph the different... oh my gosh, I'm losing the words. The different pairs of numbers that work. They're called ordered pairs. I was trying to not use the word ordered pairs, but I'm going to go ahead and use it. So the x and y combinations are called ordered pairs. If an ordered pair works, it's a solution. If you graph on the xy plane all the solutions, it makes a line. That's kind of where we're going with this, okay? So that's how this relates to what we were just doing. Every time we graph, we start at the origin. The origin is the point 0, 0. So there's 0 x value, 0 y value, okay? And it's right there. So you have in your notes the word origin where you can write the definition, and then you can label it right on the graph, okay? The x-axis is the one that goes horizontal. So it's basically a number line here, so you can count 1, 2, 3. You can also go -1, -2, -3. It's basically just a number line that's going side to side. You also have the y-axis, which is a number line that goes up and down. And the up part is the positive. So 1, 2, 3, and then the down is the negative. -1, -2, -3. So something I do to help me remember which one is which. An X is sometimes used as a way to say, like, no to someone, right? Like, which way do you shake your head if you're telling someone no? Side to side, right? So if you're giving them the X, you're like, and then Y for yes. How do you say yes to someone? Yes. No. Okay? So that might help you keep them straight. If not, you just get to see me make funny faces. So there you go. It's a win-win.
It's okay.
All right, and then we've already talked about it. This is how ordered pairs look. It's an X and then a Y, comma in the middle. You have to put the brackets around it as well. Parentheses, brackets. You know what I mean. It's definitely a Monday. I am not having a good time with my words right now. It is a Monday. That's why I'll keep mumbling all my words. Calling parentheses brackets. I can't think of ordered pair. I'm a mess. Sorry.
Are not.
All right. The first number in the ordered pair tells us what we're going to do in our X direction. So if this said like 3, for example, on the X-axis, we'd go to the 3. The second number is called our Y. It tells us what we're going to do in the Y direction. So it tells us what we're going to do up and down. Okay? All right, there's one more thing that I want you to label on here, and it's the quadrants. Quad is the way to say 4, right?
Yeah.
There are 4 sections on our graph. Those are the 4 quadrants. So this is the first one, and it kind of goes like counterintuitively. It goes counterclockwise. Normally people just do things in this rotation, so it's the opposite of that. You go here and then here. So we have the first quadrant, second quadrant, third quadrant, fourth quadrant. Here everything's positive. You go positive X, positive Y. To get to the second one, you go negative X, positive Y. The third one is a double negative, negative, negative. And then the fourth one is a positive, negative. I would not memorize that. It's very easy to see those directions as you're graphing these. Questions?
And half the time they have number spots outside.
Right. All right, so we are going to practice graphing these ordered pairs.
Yay.
So thank you for your announcement. If that's not motivating, I don't know what is. Okay, so we always start at the origin. First number tells you what you're doing left to right. Second number tells you what you're doing up or down. So I'm going to go right 2, 1, 2. I'm going to go up 3, 1, 2, 3. You're going to put a point. You're going to label that point with a capital A. Every year I see a student, they don't want to put the point. They just put an A there. I will mark those wrong, okay? You are graphing the point A. You're not just graphing a giant A. I need to see the point. Okay? Questions? All right, to graph negative 4, 1, we go back to the origin. We go left or right 4? Left 4. 1, 2, 3, 4. We go up 1. Boom. Put a point. Label it with a B. All right, point C. What am I going to do? Go right 2. Don't go up or down at all. So your Y value is 0, so you're not going up or down at all. Or you could think you're going 0 spaces. All right, point D. What am I going to do? 5 left. 1, 2, 3, 4, 5. 1 down. Put a point. Mark it with a D. All right, 3, negative 6. We go 1, 2, 3. 1, 2, 3, 4, 5, 6. And then F. So we're going to do what first? Stay there. And then go down. 1, 2, 3, 4. Mark it with an F. Those always get people, the ones with zeros. I actually make a conscious effort to do that. Like, I'm going to stay here. Then I'm going to go down 4. I don't know. That always helps me. Don't rush through it. Questions? Are we good? All right, example 2, we are going to now determine the ordered pair from the graph, and we're going to name the quadrant. So point Q, let's find it. It's right here. How do I get there? So I'm going left 4, and then I'm going up 3. How would I write that? Negative 4, positive 3, put a comma, put parentheses. What quadrant is point Q in?
2.
The second. Very good. And we use Roman numerals for those. For real. So I, Ivy. I. All right, point R. How would I get there?
2.
Right 2, up 2. So the point is 2, 2. And that is in which quadrant?
1.
The first one. I.
It's the origin. It's 0.
Yeah, this is the origin. It's 0, 0. So when it's on an axis, we don't have a quadrant. Some people put words like, it's the origin. That would be fine. Some people put if it's on one of the axes. All right, number point T.
What?
T.
Point T.
Number point. Again, I don't know what's happening between my brain and my mouth today, but they ain't communicating. 1, 2, 3, 4. 1, 2. What is it? Negative 4, negative 2, and that is in the third quadrant.
Oh, wait. No. Oh, I'm on you. See, y'all.
Getting a little chatty. All right, what about you? 2, negative 1. What quadrant is that?
4.
The fourth. Good. And V.
4.
Right 4, up 4, so 4, 4, and that is quadrant 1. All right, raise your hand if you have any questions. So your notes have something that my notes don't. So let's read through the steps. So the steps for graphing for graphing an equation with 2 variables are listed there. Okay. So the first thing you want to do is you want to get the y by itself. then we want to find 3 ordered pairs that are solutions. So 3 xy's that make it true. We want to graph those 3 points. We connect the dots. Your line must cross both the x-axis and the y-axis unless it's one of the special cases. We'll get into those. And you have to have arrows on both ends. Your best friend in this is going to be your ID because these lines need to be straight. So I always use the side of my ID instead of like a ruler or something. It's always right. It like perfect goes right there. Okay. So the first thing we want to do is solve for the y. You want to get the y part by itself. So what am I going to do? I am going to subtract the x from both sides. Now, I always sneak the x right there. You'll see why as we continue with the chapter. For now, just take my word for it. So we have y equals, it's going to be a negative x. And then is that 2 positive or negative? It's positive, so plus 2.
Oh, this is confusing.
It is like that section in chapter 1 where we solved for a variable. We're just going to solve for the y. Now, you want to make what's called an XY chart. You get to pick the x's. I always pick 0, 1, 2 unless I have a reason to pick something else. They're easy. They're fast. Do it. Okay? Now, off to the side somewhere, you want to plug these numbers in for your x. Okay? So I'm going to take x out. I'm going to put a 0 in. So I have y equals negative 0 plus 2. What is negative 0 plus 2? 2. So 2 goes there. Now I'm going to do the same thing, but with the 1. So y equals negative 1 plus 2, which is 1. Good. So a 1 goes there. Now I'm going to do the same thing, but with a 2. And yes, someone said it, 0. Now, these are 3 ordered pairs. They might not look like it. So if you want, you can write them in the format we're more used to. So this is the x, this is the y. This is the x, this is the y. This is the x, this is the y. All right? So 0, 2. I'm going to go side to side 0. I'm going to go up 2. I'll put a point.
So wait, should
These were not labeling. There's no letter associated with these. Did you have a question?
do we always use 0, 1, and 2?
Unless there's a reason to use something else. Sometimes there's a fraction and 0, 1, and 2 don't give us a lot of information. It's easier to spread them out. You are graphing it on the wrong. We're on the graph right below where we just did all the work. All right, 1, 1. So write 1 up 1, and then 2, 0. So write 2, stay right there. This is where you get your ID. And you line up those 3 points, and you connect them, and then you draw arrows on the ends. Because this graph goes on and on and on in both directions forever. Now, these graphs are super cool. Because remember at the beginning when we were plugging in ordered pairs and we were seeing if they worked? This gives you a picture of all the ordered pairs that work. So you could go like way out here and find this point. And if you plug it in, it'll work. Let's do it. 1, 2, 3, 4, 5. 1, 2, 3. So if we plug in 5, negative 3. 5 plus negative 3 is 2. It works, right? Yeah. It's awesome. So this is a basically picture of every ordered pair that's going to make those XY values true.
So cool. Turn around.
What are your questions? Any questions? Any questions at all?
Questions at the end.
All right. Now, this is what I like to call a special case. So I am still going to make an XY table for this one, or an XY chart. However, all my x's have to equal what? 3. This is one where you get to make up the y's. Someone give me a y. 0. 1. Okay, the standard. So you can make y whatever you want. X is always 3. Let's graph these. 1, 2, 3. Don't go anywhere. 1, 2, 3, go up 1. 1, 2, 3, go up 2. What kind of a line am I making? Yeah, this is a special case because it's just a vertical line. You still connect it, you still put the arrows on the ends. The way I remember these is it is a line that goes through this axis at this point. So it's going to go through the x-axis at the point 3. A lot of people get the horizontal and the vertical mixed up.
So wait, what if it was like a y equals 3? Would it just
If
be
it was a
same
y
thing?
equals 3, then it would be going through the y-axis at 3, so it'd be like this. Straight across. Okay? Questions?
Oh, man. Questions have been answered.
All right. Next. Now, on this one, we're going to have to do a little work to get the y by itself. What should I do first? First, you subtract 2x. We undo anything that's being added or subtracted first. So it's going to be negative 3y equals, slide it right up in there, negative 2x plus 3. All right, now what? Divide by negative 3, and we're actually going to divide both of these by negative 3. So every term left and right of the equal sign is going to be divided by negative 3. So those are gone. I have a y equals. This is just a fraction. Negative 2 over negative 3 is positive 2 over positive 3. Then I have my x. What is positive 3 divided by negative 3? Negative 1. Good. Okay. This is one where I would not use 0, 1, and 2. I am okay using 0.
Just 0?
Well, that's just going to give us 1 point. We still need 2 more x's. Can you think of a number that when we plug it in for the x, the fraction would go away? 6 is going to work. There's one in between 0 and 6 that will also make the fraction go away. Now, you don't have to use these. You can use any 3 x's you want. I don't want to graph a bunch of fractions. I find that to be tedious and annoying, okay? So I'm going to purposely pick x values that get rid of the fraction for me. All right? That is a personal choice of mine. Makes my life easier. I'm going to do it. Okay? If you're someone who really wants to graph 1 negative 1/3, I mean, that's your business, okay? I don't want to do it. All right. So let's do the math over here. We have y equals, I'm going to take the x out. I'm going to put a 0 in. You get negative 1. Good. So my first ordered pair is 0, negative 1. So I'm going to go side to side 0. I'm going to go down 1. You could do all the graphing at the end like I did in the first one, or you can graph as you go. I'll mix it up for you, give you some options. All right, next we're going to take the x out again, and we're going to make it a what now? A 3. The whole reason we did this is so those would go away, and I just have 2 minus 1, which is what? 1. So my next ordered pair is 3, 1. 1, 2, 3, 1. Now I'm going to do it a third time, but I am going to take the x out, and this time it's a 6. So those become a 2, right? And 2 times 2 is 4. And 4 minus 1 is 3. So my last ordered pair is 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Once you have 3 of them, get something straight, connect them, put arrows on the ends. All right, what's the first thing you did? Subtract the 3x, good. So we have y equals negative 3x plus 2. Then you picked 0 and 1 and 2. Those will definitely work. When you plug a 0 in, what do you get? You just get 2, right?
Oh, because it's multiplying by 0. So okay. Plus 2.
All right, so when you plug 1 in, what do you get? You get negative 1. Good. Shh, quiet down, guys. We're not done yet. When you plug 2 in, what do you get? That's negative 6 plus 2, which, yes, negative 4. Good. So write 2 down 4. 1, 2, 3, 4. I will connect these and put arrows on the ends. How'd you guys do? Okay, all equations that have no powers other than 1 are called linear equations because they make a line. So if you see something like an x squared, that would not make a linear graph. It would not make a line. So as long as your x and y's don't have any exponents, we're looking at a linear equation, okay? So all of these graphs should be lines. If you are getting like a zigzag or like a lightning bolt pattern, you've made a mistake, okay? So just keep that in mind. These are linear equations, meaning they make lines. All right, what do we learn about today? Today we learned what?
How to graph a linear equation.
Very good. All right, make sure you get your summary. I'm going to give you guys your homework. I'm going to give you about 8 minutes to do it, and then we'll go over that test you guys took last week. Any questions?